Hey everyone, welcome to another week of Math at Home. We're starting this week off continuing with our trig lessons and doing some review so that you have some extra practice before you have to show us what you understand so far. So this video here is going to be all about trig problem solving. We have the choices between using the primary trig ratios, so SOHCAHTOA, sine law, and cosine law. So we're going to do 3 questions together. And hopefully that helps you in your practice and also doing the quizzes. So question 1, all 3 of these are going to be word problems, which usually is what people tend to have trouble with, and so hopefully this helps. Question 1 says, a wheelchair ramp near the door of a building has an incline of 6 degrees and a rise of 0.35 meters from the ground. Calculate the run of the ramp to the nearest hundredth of a meter. So I can't stress this enough. I will probably say it a million times this video. The first thing that you want to do is draw a picture, because once you have a picture, it'll help you decide which strategy you want to use. And once you have a visual, you can add to it, and it's always going to be helpful. So give yourself a visual. Sometimes questions and textbooks, they give you pictures, and sometimes they don't. And when they don't, you need to draw that picture. So here, if we want to draw a ramp, here's my ramp with almost straight lines. Good enough. And we know that a ramp up to a building is a right angle. That's important. It says it has an incline of 6 degrees with the ground. So we'll take that 6 degrees here and we'll put it at our ramp. There's our 6 degrees with the ground. So we're assuming that this part here, that's our ground. And it also says it has a rise of 0.35 meters, which means that this part here, the horizontal part is our run, the vertical part is our, not run, rise. There we go. And it's 0.35 meters, so we can label this right here 0.35 meters. Perfect. So since we have a right angle, that's automatically probably a good idea that you want to use when you have a right angle is your SOHCAHTOA, because it can only be used with right angle triangles. We tend to use sine law and cosine law because we don't have right angle triangles, but here we do. So we want to decide, am I going to use sine, cosine, or tan? Well, I don't know that yet until I label my sides. So from basing it off this 6 degree angle, we can label opposite, we can label adjacent, and we can label hypotenuse. So now that that is all said and done, we see, what do we have? We have the opposite, and what are we looking for? Well, the question wants us to find the run. So we have the opposite, and we're looking for the adjacent. Looks to me like the only thing that has opposite and adjacent is tan. So we want to use tan. So we're going to set up with our tan of 6 degrees is equal to opposite over adjacent. It's up to you if you want to replace adjacent with a variable such as x, or you can leave it as a. It's fine by me. So we want to fill in what we know. So right now we know that tan of 6 degrees is equal to 0.35 over this unknown angle, which is our adjacent. So to solve this question, the easiest way to do this is put that left side, the tan 6, over 1. And that way we have 2 fractions with an equal sign in between them, and we can do cross multiplication to try to get our variable by itself. So if we do cross multiplication, we do a times tan 6, which is a tan 6 degrees. We can put it in brackets if we want, equals 0.35. Well, we are trying to get this a by itself. We're trying to find what is the value of a. So to get that by itself, we are going to divide both sides by tan 6 degrees. So that will leave us with just, there we go, just a. And if we take out our handy dandy calculators, 0.35 divided by tan 6 gives us 3.33 meters. So we would say, therefore, the run of the ramp is 3.33. Meters, don't forget your units. So our next question, let's take a look. CJ is flying a kite on level ground, and the string forms an angle of 50 degrees with the ground. Two friends, Ben and Kevin, standing near each other some distance away from CJ, see the kite at angles of elevation of 66 degrees and 35 degrees, respectively, meaning that Ben sees the 66 and Kevin sees the 35. Ben is 11 meters away from CJ, and Kevin is an unknown distance a little bit further away. So there's two parts here, part A and B. We're going to do part A together. And part B, I'm going to let you try on your own, and I will post a PDF with the full solutions so you can check your answers. So again, as I said before, the first thing that you want to do is draw yourself a picture, or else this is just a whole bunch of words and that don't make any sense. So we can start off with saying that here's CJ, and here he is holding his kite. So we'll just draw off to the side, here's that, wow, not a great kite. There we go, and that's the kite string. So let's just call this line his line of sight. But yeah, he's holding onto the kite, and he's also 11 meters away from Ben. So we can put B for Ben. And this line here will be Ben looking up to the top of the kite. We know a little bit further away we have Kevin, so we can call it K. And this is him also looking up to the top of the kite. What else do we know? We know that the string forms an angle of 50 degrees with the ground, so we definitely have that piece of information over here. We know that the angle of elevation for Ben is 66 degrees, so angle of elevation meaning like when you're looking straight ahead and then your eyes look up towards the object that you're looking at, in this case the kite, that angle that your eyes have made from that straight across view to looking up, that's your angle of elevation. So there's our 66 degrees, Ben looking up to the kite, and Kevin, same thing here, 35 degrees. And the question in part A says, how high is the kite above the ground? So if we want a height to visualize this, we're looking at this right here. That vertical height, that making a right angle with the ground, how high is that top of the kite above the ground? So there's a lot going on in this question, and it might take us a couple of steps to get there, because overall it looked like we didn't have any right angle triangles, and now we do, and at the end we're looking for this, let's call it X, the height of the top of the kite. So we know for right angles, we said we want to use SOHCAHTOA, but right away we don't really have enough information to use SOHCAHTOA. We know that this whole entire bottom is 11 meters, but splitting it up, we don't know what's what. And we don't have any other lengths to help us out. We just have angles. So let's backtrack a bit and see if we can find out any other piece of information. So let's erase that for a second here. We'll come back to the height, but beforehand, do we know anything else? So it looks like we have two angles out of 3 in this triangle. So we can find that third angle by subtracting 50 and 66 from 180, and we will get 64 degrees. So let's pop that in there. So okay, 64 degrees is at the top. And we know that if we want to eventually use SOHCAHTOA, we need one of these two side lengths. And it's up to you what you want to go first with it. It won't really matter in the end. It'll help us out. But I know that in the next question, we want to find out how far is Kevin from CJ, which is this one. So maybe for the interest of saving some time or being strategic, let's find out this side length here. So I'm going to call this Y and say that's what we're looking for. So it looks like we have a not right angle triangle, and it looks like we also have some matching sets of side length and opposite angle. So right here I see that 64 degrees and 11 match up. I know we have that missing Y, but we do know the angle that's across from it. So when we have those matching pairs, we know that probably sine law is a good idea, and we'll also see it in the next question how it's easier to tell cosine law first and then rule it out. But here we have two matching side lengths, so let's use our sine law to figure out what Y is. So if we set it up, we will have, to find y, we would say y over sine 50 degrees is equal to 11 over sine 64. So putting those matching pairs together. Doesn't matter if you like it the other way around and you put sine 50 over y equals sine 64 over 11. Nope, you're totally fine doing that too. It doesn't matter. So just like in the last question that we did, since we have two fractions on either side of the equal sign, or separated by an equal sign, we can do our cross multiplication. It makes our lives so much easier. So this is going to turn into y sine 64 equals 11 sine 50. Perfect. We are trying to get this y by itself, so we're going to divide both sides by sine 64. Get that. We want y by itself, and we end up with, plug it in your calculator, test it out, we will end up with 9.4 meters. So we can go back into our drawing, which, I kind of ruined with the blue, but we can erase that to make it a little bit more clear. Perfect. So we can now add to our drawing that it's actually 9.4 meters. So let's put that in right here, that this is 9.4 meters. Right here. So now we can go back to our original goal, which was to find the height. So we'll put our height back down here, and we'll put our right angle there. So we know again that we can use SOHCAHTOA. This was like our step 1. And now we want to take a look at SOHCAHTOA because we are working with a right angle again. And the only angle that we know for sure here is 66 degrees, because now that 64 degrees is split up and we don't know how much of it is on either side of that dotted line. But we know for sure that that 66 is in this side of the triangle. So we can label based off of 66 degrees. So we know that this is the hypotenuse, this is our opposite, and this is our adjacent. And we know for sure that the goal is to find that x, this height of the triangle. So we're looking for the opposite, and we have the hypotenuse. So the only one that we can use that has opposite and hypotenuse is going to be sine. So there we go, let's circle our sine, and we can set it up. So we can say sine of 66 degrees is equal to opposite over hypotenuse. Fill in what you know. Opposite is x, we don't know. But hypotenuse we do know, which is 9.4 meters. And again, we can do the same thing, which is put that left side over 1, and then we can cross multiply. This time cross multiplying gives us a nice answer. X times 1 is just x, so we already have x isolated. And we have 9.4 times sine 66. We can put it all together and say 8.6 meters after you plug it into your calculator. So again, how high is the kite above the ground? After all that work, we find out that it is 8.6 meters. So we're finally at our last question. While golfing, Mahmoud hits a tree shot from T towards a hole at H, but the ball veers 23 degrees and lands at B. The scorecard says he is 270 meters from T. If Mahmoud walks 160 meters to the ball, B, how far to the nearest meter is the ball from the hole? Again, step 1, we're going to draw a picture. So let's go with, he's starting at T. So he hits a tree shot from T towards a hole at H. So he's trying to hit towards a hole at H. But the ball veers 23 degrees away from the original and actually lands at a different spot called B. That's where the ball is. So it actually veers 23 degrees. It was supposed to be going in this direction, but it took a little turn this way. So we can actually turn this into a triangle. And the scorecard says that he is 270 meters from T. Then by he, that's actually supposed to be H. So let's just change that. There we go. H is 270 meters from T. If Mahmoud walks 160 meters to the ball B, so 160 meters to the ball B, how far to the nearest meter is the ball from the hole? So we are trying to find out this length here. Let's call it x. So there are two situations where you would want to use cosine law, and it's really what you want to check for first before you can say, you know what, actually, I'm going to use sine law. Or we can say that we don't have any like matching pairs here. We don't really know any of the other angles, so there's no, we can match up 23 and x, but we can't match up anything else. And basically, we know that we can use cosine law if either one, you have all three side lengths. You don't need any angles, but you would need all three side lengths. Or you have two sides and the angle in between, which is exactly what we have. We have side, and we have angle, which I kind of like to call the pizza slice. So here's our two. Basically, we have this corner of the pizza. So we definitely want to use cosine law here. How does that work? Let's go take a look. So obviously, we usually see A, B, and C as the letters for cosine law. Probably commonly you see c squared equals a squared plus b squared minus 2ab cos of capital C. However, we don't really have a, b, and c in this, so we have to change it up a bit. Really what we want is to remember that the letter that goes over here in the beginning is the side length that you're looking for. And it matches up with, at the end, that's the angle that's opposite to the side length that you're looking for. And these are just the other side lengths, and it doesn't matter which order that they go in. So we're going to replace this. So we know if that's capital T, this is little t, capital B across is little b, capital H across is little h. We know that we're looking for little t, so when we rearrange this, we're going to call this little t squared equals, doesn't matter, so we can do b squared plus h squared, keep it alphabetical, minus 2bh cos of capital T. That's the angle that we have. So now we've just rearranged that equation. And now that we've done that, it's a lot easier to just put our letters in here. So we don't know what T is, but we are just calling it H for now. You don't have to. You can even just have left it as little t. It doesn't really matter. So we'll call this for now x squared, since I already did that, equals 270 squared plus 160 squared minus 270, 160 cos of 23 degrees. So you have that whole thing set up. You can pause it and try it on your own and check back for the answer. So I'm not going to go into super detail. I think you can square numbers in your calculator. 9. Oh, I definitely did that in the wrong order. Okay, we got 72,900 plus 25,600 minus 86,400 cos 23. What you want to be careful of is when you put these together, you don't subtract this 86,400 that is attached to the cos 23 by multiplication, so you need to follow BEDMAS. So our next line here should look like x squared is equal to 98,500 minus 86,400 cos 23. Could you put that as a decimal all together over here? Sure, doesn't matter to me. But what we do know is that our final step needs to be square rooted. So you can put that as a decimal if you want to and then square root it, but we know that we don't want x squared, we definitely want x. So to get x by itself, we square root it, and in the end, after rounding to the nearest meter, because if we go up, we see to the nearest meter, we're going to go back down, and our final answer is 138 meters. Good luck with your homework and the quizzes this week.